Binder jetting is a process where the material being jetted is a binder and is selectively sprayed into a powder bed of the part material to fuse it a layer at a time to create or print the required part. As is the case with other powder bed systems, once a layer is completed, the powder bed drops incrementally and a roller or blade smoothens the powder over the surface of the bed prior to the next pass of the jet heads, with the binder for the subsequent layer to be formed and fused with the previous layer. The advantage of this process include the fact that the need for support is negated because the powder bed itself provides this functionality. Furthermore, a range of different materials can be used, including ceramic and food. A further distinctive advantage of this process is the ability to easily add a full color palette, which can be added to the binder. The next process is material jetting. It is a 3D printing process whereby the actual build material are selectively jetted through multiple jet heads. However, the materials tend to be liquid photopolymers, which are cured with a pass of ultraviolet light as each layer is deposited. The nature of this process allows for the simultaneous deposition of a range of materials, which means that a single part can be produced from multiple materials with different characteristics and properties. Material jetting is a very precise 3D printing method, producing accurate parts with a very smooth finish. SDL or Selective Deposition Lamination is a proprietary 3D printing process developed and manufactured by MCOR Technologies. The SDL 3D printing process builds part layer by layer using standard copier paper. Each new layer is fixed to the previous layer using an adhesive, which is applied selectively according to the 3D data supplied to the machine. This means that a much higher density of adhesive is deposited in the area that will become the part, and a much lower density of adhesive is applied in the surrounding area that will serve as the support. SDL is one of the very few 3D printing processes that can produce full color 3D printing parts using a CYMK color palette. The last 3D printing process that we are going to cover in this course is electron beam melting or EBM. The heat source is an electron beam rather than a laser, which makes it necessary that the procedure is carried out under vacuum conditions. EBM has the capability of creating fully dense parts in a variety of metal alloys, and as a result, the technique has been particularly successful for a range of production applications in the medical industry, particularly for implants. The materials available for 3D printing have come a long way since the early days of the technology. There is now a wide variety of different materials that are supplied in different states. Specific materials are now generally developed for specific platforms performing dedicated applications. An example of such dedicated application would be the dental sector. In this lecture, we shall look into the most popular types of generic materials available for 3D printing, starting with plastics. When it comes to plastics, we have nylon or polyamide, which is commonly used in powder form in the sintering process, or in filament form in the FDM process. It is a strong, flexible, and durable plastic material that has proved reliable for 3D printing. It is naturally white in color, but it can be colored pre or post printing. This material can also be combined with powdered aluminum to produce yet another common 3D printing material called alumide for sintering purpose. ABS is another common plastic used for 3D printing and is widely used as an entry-level FDM 3D printer filament. It is a particularly strong plastic and comes in a wide range of colors. ABS can be bought in filament form from a number of non-proprietary sources. This made the filament very popular in the market. PLA, on the other hand, is a biodegradable plastic material that has gained traction with 3D printing for this very reason. It can be utilized in resin format for DLP process as well as in filament form for the FDM process. It is offered in a variety of colors, including transparent, which has proven it to be useful for many applications of 3D printing. However, PLA is not as durable as compared to ABS. The next material is the metal. A growing number of metal and metal composites are used for industrial grade 3D printing. Two of the most common metals are aluminum and cobalt. One of the strongest and therefore most commonly used metal for 3D printing is stainless steel in powder form. This is generally used for EBM process. It is naturally silver but can be plated with other materials to give a gold or bronze effect. In the last couple of years, gold and silver have been added to the range of metal materials that can be 3D printed directly. And hence, the obvious application of gold and silver is the jewelry sector. These are very strong materials and are processed in powder form. The next material would be ceramic. Ceramics are a relatively new group of materials that can be used for 3D printing purpose. The particular thing to note with this type of materials that post-printing, the ceramic parts needs to undergo the same process as any ceramic part made using traditional method of production. The next material is paper. Standard A4 copier paper is a 3D printing material employed by the SDL process developed by MCOR technologies that we have discussed earlier. 3D printed models made with paper are safe, environmentally friendly, easily recyclable, and requires no post-processing at all. The next material for 3D printing are biomaterials. There is a huge amount of research being conducted into the potential of 3D printing biomaterials for a myriad of medical applications. Living tissues is being investigated at a number of leading institutions with a view to developing applications that include printing human organs for transplant, as well as external tissues for replacement of body parts. The next 3D printing material is food. Experiments with extruders for 3D printing food substances has increased dramatically over the last couple of years. Chocolate is the most common one. There are also 3D printers that work with sugar, and some experiments with pasta and meat are undergoing. The origins of 3D printing in rapid prototyping were founded on the principles of industrial prototyping. as a means of speeding up the earliest stage of product development. Prototyping is still probably the largest application of 3D printing. The developments and improvements of the process and the materials since the emergence of 3D printing for prototyping saw the processes being taken up for applications further down the product development process chain. Tooling and casting applications were developed utilizing the advantages of the different processes. Again, these applications are increasingly being used and adopted across industrial sectors. Similarly, for final manufacturing operations, the improvements are continuing to facilitate uptake. In terms of the industrial vertical market that are benefiting greatly from industrial 3D printing across all of these broad spectrum applications, we are going to make a basic breakdown of major 3D printing applications. First being the medical sector. The medical sector is viewed as an early adopter of 3D printing. It's also a sector with huge potential for growth due to the customization and personalization capabilities of the technology and the ability to improve people's lives as the process improve and materials are developed that meet medical grade standards. 3D printing technologies are being used for a host of different applications. In addition to making prototypes to support new product development for the medical and dental industries, the technology is also utilized to make patterns for the downstream metal casting of dental crowns and in the manufacture of tools over which plastic is being vacuum formed to make dental aligners. The technology is being used to directly manufacture both stock items such as hip and knee implants and bespoke patient-specific products such as hearing aids, orthotic insoles for shoes, personalized prosthetics and one-off implants for patients suffering from diseases such as osteoarthritis, osteoporosis and cancer. 3D printed surgical guides for specific operations are also an emerging application that is aiding surgeons in their work and patients in their recovery. Technology is also being developed for the 3D printing of skin, bone, tissue, pharmaceuticals, and even human organs. However, these technologies remain largely decades away from commercialization. Like the medical sector, the aerospace sector was an early adopter of 3D printing technologies in the earliest form for product development and prototyping. Another general early adopter of rapid prototyping technology was the automotive sector. Many automotive companies, particularly Formula One, have followed a similar trajectory to the aerospace companies, not only using the technologies for prototyping applications, but also for developing and adapting their manufacturing processes to incorporate the benefits of improved materials and results for automotive parts. Many automotive companies are now also looking at the potential of 3D printing to fulfill after-sales functions in terms of production of spare parts. Now for the jewelry sector, 3D printing has proved to be particularly disruptive. Traditionally, the design and manufacturing process for jewelry has always required high levels of expertise and knowledge involving specific disciplines. Each of these disciplines evolved over many years and each required technical knowledge. Just one example is investment casting, the origin of which can be traced back more than 4,000 years. There is a great deal of interest and uptake based on how 3D printing can and will contribute to the further development of this industry. Artists and sculptors are engaging with 3D printing in myriad of different ways to explore form and function in ways previously impossible. Whether purely to find a new original expression or to learn from old masters, this is a highly charged sector that is increasingly finding new ways of working with 3D printing and introducing the results to the world. There are numerous artists that have now made a name for themselves for working specifically with 3D modeling, 3D scanning, and 3D printing technologies. Architectural models have long been a staple application of 3D printing processes for producing accurate demonstration models of an architect's vision. 3D printing offers a relatively fast, easy, and economically viable method of producing detailed models directly from 3D CAD, BIM, or other digital data that architects use. Many successful architectural firms now commonly use 3D printing as a critical part of their workflow for increased innovation and improved communication. More recently, some visionary architects are looking to 3D printing as a direct construction method. Research is being conducted at a number of organizations on this front. 3D printing houses is not a dream anymore. 3D printing accessories, including shoes, headpieces, hats, and bags, have all made their way onto the global catwalks. And some even more visionary fashion designers have demonstrated the capabilities of the technology for haute couture. Dresses, capes, full-length gowns have debuted at different fashion venues around the world. Iris Van Herpen should get a special mention as the leading pioneer in this sector. She has produced a number of collections modeled on the catwalks of Paris and Milan that incorporated 3D printing to blow up the normal rules that no longer apply to fashion design. Many have followed and continue to follow in her footsteps. Although a latecomer to 3D printing, food is one emerging application that is getting people very excited and has the potential to truly take the technology into the mainstream. 3D printing is emerging as a new way of preparing and presenting food. Initial forays into 3D printing food were with chocolate and sugar, and these developments have continued with specific 3D printers hitting the market. Some other early experiments with food include the 3D printing of meat at the cellular protein level. More recently, pasta is another food group that is being researched for 3D printing food material. For 3D printing, the holy grail for 3D printing vendors is undoubtedly consumer 3D printing. There is a widespread debate as to whether this is a feasible prospect in future. Currently, consumer uptake is low due to the accessibility and application issues that exist with entry-level machines. There is headway being made in this direction by the larger 3D printing companies such as 3D Systems and MakerBot, as they try to make the 3D printing process and the ancillary components like software, digital contents, and materials more accessible and user-friendly.